Hi, in this video I'm going to present the setup about particle contact electricity. I am in Politecnico di Milano lab, and basically what I will do is to make this impeller rotate inside an electrically insulating liquid. Particles will be dispersed inside this liquid and the collision will generate electricity. So this impeller is made by a PVC tube. At the end there is the actual impeller, that is a 3D printed structure, and there are 4 copper electrodes placed on the impeller that are electrically connected to an aluminum tape. So this impeller will rotate inside this conductive cage made by copper and this conductive metal wire, and this will be placed inside this plastic container where the liquid containing the particles will be placed. The rotation of the impeller is made possible by this structure, so the impeller can be connected here, and using this electric motor and this generator it is possible to make the rotation occur. Using this terminal it is possible to electrically access to the rotating electrodes. This happens because of this rotating contact. There are copper threads that are in contact with the aluminum tape. And finally, it is important to mention that the rotation speed can be measured using this optical tachometer. Here there are the 2 measurement devices that are used. Here we have a simple tester that is in voltage measurement mode. The electric current produced with this setup is small, about the nanoampere. So by measuring the voltage it is possible to estimate the current. This tester has an internal resistance of 10 megaohm, so 10 millivolts here correspond to 1 nanoampere. And this second device is used to have a second check on the current generated, and it is also used to measure the high resistances involved in this setup. Finally, the insulating fluid used is the mineral oil, and the particle dispersed will be talc particles, even if many other particles, many other powders can be used, like plastic powders. Now the impeller is ready to rotate inside the cage collector, and I have connected the positive terminal of the tester to the rotating electrode, while the negative black terminal is connected to the collector. It is possible to see that if I switch the tester into resistance measurement, the resistance is very high, more than 200 megaohms. So now I switch back to voltage measurement, to millivolts measurements, and I can make the impeller start to rotate. I can measure the rotation speed using the optical tachometer. The rotation speed is around 460 RPM, and no current is produced right now because the impeller is rotating in air. Now I have added around 700 millimeters of mineral oil inside the container. The electric resistance is always greater than 200 megohms because mineral oil is an electric insulating fluid, and if the impeller is made to rotate, it will be possible to observe now that a very small current is generated inside the oil. So if I made it stop to rotate, slowly it will go down to 0, and if I will start again to make it rotate, the current will be generated again. I have now filled the oil with talc particles, so that now it is possible to produce electricity by the collision of these particles. The volume of the mixture has increased, so I take it out a little bit in order to have always 700 millimeters. I have added 350 grams in the 700 millimeters of oil, so that is the actual concentration of the particles. And you can see that now the tester is in voltage measurement mode, measuring 0.0 millivolts, while there is no rotation of the impeller. And now I'm going to start the rotation. So now it's going very slow. There is only 1 volt on the voltage generator that is giving power to the electric motor. Now I'm going to give 2 volts. You can already see that on the tester there are 12 millivolts, so 1.2 nanoampere are generated right now. And if I keep increase the speed of rotation, also the current produced will increase. Now I'm at 3 volts of the electric generator voltage. Now I am at 4 volts of the electric generator voltage. I'm still increasing a little bit. I'm reaching 5. Now I have reached 5 volts on the electric generator. We are producing 13 nanoampere. The rotation speed is a little bit less than 600 RPM. I will keep increasing. Now I'm about to reach 6 volts. Now here I have to change the scale. The tester is signing almost at 0.2 volts. I will keep increasing the rotation speed. Okay, I have reached 7 volts. That is a rotation speed of 830 RPM, and it is now producing 23 nanoampere. And now I will suddenly close the speed of rotation, and the current generator will go to 0. I have connected the high resistance meter in order to measure the resistance of this mixture. And if I apply 10 volts, the scale is 100 gigaohm, 10 to the power of 11. And if I put in measurement mode, you can see that the pointer now is moving because it is very sensible to the motion of my hand. But if you can see, the pointer is at 3, 4. This is giving that lecture, so the resistance of the mixture is almost 400 gigaohm. Now I'm doing the same experiment, but with a bigger impeller. This was the one used previously. This is the new one that I'm going to test, and the new impeller will be tested in a bigger volume with a collector similar to the one used before. So this suspension has a lower torque concentration, and this will produce less current but higher maximum voltages. And so what I've done here is to connect the rotating electrodes to and the collector to these two copper foils that are on a piece of rubber, and the goal is to just observe sparks between these two copper foils that are a sign of high voltage. I will start to make this rotate. At 5 volts. Now if I touch one of the two coppers and put it closer, yeah, you can see it. Sparks can be generated. It is also possible to use this electroscope in order to observe the voltage that this suspension is able to generate when a rotation is occurring, and it must be an electrostatic voltage device, because otherwise the current will be dissipated in the internal resistance. So this in particular, this device is capable of measuring from 0 to 1500 volts. So I will start the rotation. Okay, this at 3 volt is slowly rising. Now it is about 500 volts that are generated between the rotating electrodes and the collector. Here the rotation speed is 300 RPM. Yes, now the electroscope is signing 650 volts. I will increase the speed and I will reach 5 volts. Now the voltage is over 1000 volt and is reaching the limit of the device. 1300, 1400. So the tester is set in millivolts measurement, so it's not anymore 0.0, but it is just 0 millivolts. It will start from that, and I'm going to start the rotation. Now I am at 2 volts of the electric generator, and I am already generating 3-4 nanoampere. I will increase at 3 volts of the electric generator, and I am about to reach 10 nanoampere. Now the rotation speed is 300 RPM. Will keep increasing. Four volt. 5. 6 volt. 7 volts, producing 550 nanoampere, more or less. It's oscillating a lot. And now I'm going to 0 again.